In this lecture, we'll talk about in this lecture, we'll talk more about RDDs and the characteristics of RDDs and why they are called basic units of data structures in API, and also when we use RDD and when we use data frames, and what are the disadvantages with RDDs. Well, get well, we dive into that. So, what are RDDs? So, RDDs are abbreviated as Resilient Distributed Datasets. RDDs or resilient distributed datasets is a collection of records with distributed computing which are fault tolerant, immutable nature. They can be operated in parallel with low level APIs, while their lazy feature makes Spark operation to work at an improved speed. And RDD support two kinds of operations, namely transformation and other is action. Well, I'll discuss that in detail about each characters of RDD. So for that, let's jump into the notepad. So let's understand about RDD by understanding what are the characteristics of RDD. So RDD provides distributed data abstractions. So what does it mean? Let's say we have a data of huge size and it is stored in HDFS. HDFS provides this architecture of distributed storing and across clusters or partitioning across nodes. So what is the very use of this distributed storing? We can perform parallel operation. So RDDs provides this feature of distributed computing and parallel operation. And the second is resilient and immutable. So what do I mean by immutable? Any operations on RDDs are not in place operations, meaning that if there is any transformation executed on RDD1 and stored it is an RDD2, then we have the track or the knowledge of RDD1. Even we can perform another transformation in RDD1 and store it as RDD5 as well. So meaning that those operations were not in place operations. And third is data can be structured or unstructured, meaning RDD doesn't care about schema of the data stored or provided. The user has to be very specific about what, not just about what to do but also how to do an operation. And fourth is lazy evaluation. So what does lazy evaluation refers to? Unless there is a particular action specified, transformation doesn't really happen or technically takes place. That means, let's say that we have created an RDD4 which is performed or created using some transformation on RDD3, which is created using some transformation on RDD2, which is created using some transformation on RDD1. So unless we specify any action on any of the RDDs, unless we specify any action, those transformation doesn't really takes place. This is the feature of lazy evaluation. So the whole operations that can be performed using RDD are classified into two types. Those were transformation and actions. So some of the transformations are map, filter, flat map, sample, map partition, group by, union, intersection, zip, or key. And some of the actions are reduce, collect, aggregate, fold, first, take, top, max, sum, count. So let us also specify when to use or why to use RDD. So well, when user is working with low level APIs, as RDDs are low level APIs, when user is working with low level APIs, then RDDs has significance. And RDDs offer control and flexibility, meaning that user can specify each and every operation, not just what to do but also how to do an operation, so which gives control over the operations. And it is type safe, meaning that let's say that we have a knowledge of some RDD of integer type and we perform some operation of string type, so then RDD throws an error saying that we have performed a wrong kind of operation. That refers to type safe. And user has to be specific with how to do a function or how to do any operation. When user has to be very specific about how to do a function, then RDDs are significant to use. And when user is dealing with unstructured data, so as RDD doesn't care about schema of the data, user can specify what to do and how to do. And when user doesn't care about optimization and performance, meaning that if user wish to have control over every operation, then he has to sacrifice on any of these concepts of optimization or performance. And if user doesn't care about optimization or performance factors, then RDDs can be used. So what are the disadvantages of using RDD? RDDs work slow with non-JVM languages. JVM refers to Java Virtual Machines. So Python is a non-JVM language. So when we are working with Python, then RDDs work slow, meaning they take much time. So it will cost. User has to be very specific about actions and transformations and has to optimize each and every RDD, meaning that RDDs are not user friendly to use. And let also see that what are the structured APIs that Spark provides. So the other two APIs that Spark provides are data frames and datasets. These are termed as structured APIs because most of the data that we use, that we work with, data frames and datasets are structured data. And yes, when working with data frames, Python could be a good choice of language. And Python has this inability to work with datasets. So when we are working with datasets, then we have to use either Scala or R languages. So yeah, that is for this lecture, and let's revise what all we have seen for this lecture. So yeah, we have seen what are the characteristics of RDDs. So understanding about those characteristics, we have understood what are RDDs, and those characteristics are distributed data abstraction, resilient and immutable. Data can be structured or unstructured, lazy evaluation, and also seen why or when to use RDD, what are the disadvantages with RDD, and also seen the structured, what are the kinds of structured APIs that Spark provides, and what are the languages specific towards these structured APIs. So let's meet in another lecture.